Number 51, as a runaway scientific balloon ascends at 19.6 meters per second, one of its instrument packages breaks free of a harness and free falls. This figure over here gives the vertical velocity of the package versus time, from before it breaks free to when it reaches the ground. Letter A, what maximum height above the break-free point does it rise? Letter B, how high is the break-free point above the ground? So what's happening here? We have a balloon, a scientific balloon. I'm not sure if this represents a scientific balloon, it's just a regular balloon. So the balloon is going up at an initial velocity of, let's say it's V0, of 19.6 meters per second. Let's say that upwards is the positive direction and downwards is the negative direction, so this is plus 19.6. So after 2 seconds of a package traveling inside the balloon, the package falls. However, the initial velocity of the package is the same as the balloon, 19.6. So when the package leaves the balloon, it goes like this. It goes up a little bit and then goes down, because its initial velocity is not zero. Its initial velocity is this one over here. And we know that this happens, not this point. We know that the package leaves the balloon when the clock marks 2 seconds. Because you see, this is the velocity of the package, and the velocity of the package is constant. So up to this point, the package is inside the balloon. And when the clock marks 2 seconds, the package leaves the balloon and start doing this movement. In letter A, the problem wants us to calculate this height over here, and letter B is this height over here, right? This is age 2. So let's call this age 1 and this age 2. So this is what we want to know. So how can we calculate age 1 over here? We know that at the top of the trajectory, the top point of the trajectory, the velocity is 0 because it's changing the velocity from upwards to downwards. This is the velocity, it's 0. You could find from the graph over here that these points happen here because the velocity is 0, you can see that. Or you can make the calculations. Let's write v equals to v0 plus at. Remember that the acceleration is the acceleration of gravity, which is minus 9.8 meters per square second. The initial velocity is plus 19.6. It's 19.6 meters per second. So you can isolate t over there. So t would be v minus v0 over a. V is 0 because the velocity is 0 in this point. So it is 0 minus 19.6 over minus 9.8, which gives us 2 seconds. Just notice here that this 2 seconds is after the package breaks free. So this is 2 seconds, right? Don't make confusion about this scale and the scale after the package breaks free. So when the clock marks 4 seconds is when the package reaches the maximum height of the trajectory. However, we don't need the information of 4 seconds. We can use 2 seconds. And how we will find this age 1? Just remember that x equals to x0 plus v0t plus at squared over 2. Let's say that x0 is the position where the instrument leaves the balloon, so this is x0. And we want to find x, which is age 1 in this case. So age 1 equals to 0 plus the initial velocity, 19.6 times 2 seconds, because this position happens 2 seconds after the package leaves the balloon, plus minus 9.8 times 2 squared over 2. And this is, let's see, this is 39.2 for 39.2 minus, and this is 2 times minus 19.6, and this equals to 19.6 meters. So this is the answer of the first part of the exercise. So this is the answer of this part over here. So letter B, how high is the break free point above the ground? So we can do almost the same thing as we did over here. We just changed the initial and the final position. Let's say that we want to find x0, and let's call the ground 0 meters. So we can write the same equation again, x equals to x0 plus v0t plus at squared over 2. And we know that it leaves the ground at 8 seconds, but this is not 8 seconds that we have to use at the equation. This is 6, right? This is 6 seconds after the package breaks free. So, okay. So the final position is 0. The initial position is 82, plus the initial velocity, which is 19.6. We have 6 seconds after the package breaks free, minus 9.8 times 6 squared over 2. And then we find that A2 is equal to 59 meters, roughly 59 meters. So this is the answer of letter B.